Good morning, everyone. Today we will see fractional knapsack problem using greedy technique. So greedy technique is a main important problem solving technique uh, that can be applied to solve many problems. In this session, we will see fractional knapsack problem, how to solve fractional knapsack problem using greedy technique. Before going into this, we will see what is greedy approach. Greedy approach solve the problems in multiple stages. At each stage, there are n number of local optimal solutions. Greedy approach choose the best local optimal solutions that that can be extended to the next level to reach the final global solutions. That is, greedy approach used to solve optimization problem. So optimization problem can be maximization problem or minimization problem. For some problems, the value should be minimized or maximized. For example, profit should be maximized, or the cost, distance, or time, that factors can be reduced, should be minimized. So based on the type of problem or the objective of the problem, we can say is a maximization problem or minimization problem. So in greedy approach, the problem can be solved in multiple steps. At each and every steps, there are n number of solutions. The best solution is taken that can be extended to the next level to reach the final global solutions. And it is very easy to understand and implement. What's the knapsack problem? Knapsack is a container as a bag. It has some capacity, and there are n number of items. Each item has value and weight. And the problem is we have to find the subset of items that fit into the knapsack. So there can be n number of subsets. So our aim is to find the subset with maximum value. Maximum value is each item has a value. The sum of value of all the items that is added into the knapsack, that value should be maximum. This is example for maximization optimum solution problem. So here the input is knapsack capacity is given C, set of n objects, that is O1 to ON. Each object has WN to WN weight and the profit or the value P1 to PN. So the constraint, what's the constraint? When we add the objects in the knapsack, total weight of the items should not exceed the capacity of the knapsack. That should be total weight should be less than or equal to knapsack capacity. That's a constraint. So there are n number of solutions that satisfy the constraint, and that is called feasible solutions. Here the problem objective is to find the optimal solution. So which feasible solution has the maximum value, that is optimal solution. So here the output is some subset of objects with maximum profit or value. For example, we have the knapsack bag C. So there are two items, weight to first item, the weight is 2 kg and the value is 14. For the second item, the weight is 4 and the value is 10. So when we add the objects or items into the knapsack, we're adding the value or profit also. So that should be maximum. That is a knapsack problem. That is, it is a type of optimization problem. There are n items with the weight W1 to Wn and the value is V1 to Vn and the knapsack capacity is W. Find the subset of items whose sum of weight is equal to less than W and the total value should be maximum. So greedy approach solve the fractional knapsack problem. The knapsack problem can be divided into two types. That is 0-1 knapsack problem and fractional knapsack problem. 0-1 knapsack problem, the product cannot be partitioned or fractioned. The whole items can be added to the knapsack or not added. 1 means the item is added to the knapsack, or 0 means the item is not added. In the case of fractional knapsack problem, the product can be partitioned or fractioned. For example, one item weight is 5 kg. So we can divide based on the availability of knapsack capacity. So we can divide the given items into subparts. For example, 5 kg, 2 kg, and 3 kg. 2 kg can be added to the knapsack. 3 kg cannot be added. So the product can be divided or partitioned. That is called fractional knapsack problem. 0, 1 means the product cannot be partitioned or fractioned. Either whole object can be added or not added. And fractional knapsack problem, the product is 5 kg. So we can partition into 2 kg and 3 kg. 2 kg can be added or 3 kg can be added or 1 or 4 kg. Any partition can be added to the knapsack or whole items can be added. In the case of 0, 1 knapsack problem, the product cannot be partitioned. So the fractional knapsack problem can be solved using greedy approach. So what are the steps for solving fractional knapsack problem using greedy approach? There are 5 steps. So each item has value and weight ratio. Calculate value to weight ratio for n items. The ratio of item I is Vi to Wi. So value of item I divided by weight of item I. That is the ratio. For n items, the ratio is calculated. And the second step, sort the items based on the value to weight ratio in descending order. So that is the first item has the highest ratio value. Second items has lesser than first and greater than third. So like that, the items are sorted in descending order of value to weight ratio. And after the sorting, we are ready to add the items into the knapsack. So each knapsack has the capacity. When we add the item to the knapsack, we can add the total weight and the total value. Initially, the knapsack is empty. So total value and the total capacity is 0. So when we add the items, the capacity and the value can be increased, added with the corresponding item value and weight. And so select the item to the based on the highest value to weight ratio, and that can be added to the knapsack. If the item fitted to the knapsack, fit means total weight of the object should be less than or equal to knapsack capacity, should not exceed the knapsack capacity. If not, if we add the item, the total weight exceeds the knapsack capacity, we cannot add it. So it's not does not satisfy the constraint problem constraints. So what we can do? The given item can be fractioned or partitioned based on the requirement or available capacity of the knapsack that fit into the knapsack. So then add the fractional part into the knapsack till this process 3 and 4 is repeated till all items are over or the knapsack capacity is full. So after adding all the items, the knapsack capacity can be full or the knapsack capacity should be greater or equal to the total weight of the item that is available in the knapsack. That is the process of knapsack problem using greedy approach. We will see one example. There are 3 items, 1, 2, 3. Each item has weight and value. And the knapsack capacity W 15 kg is given. So what's the first step? Calculate the value to weight ratio. For the item 1, value is 15 divided by 5. Weight. So 3.0. So for all the items, the ratio is calculated. And the second step is sort the items in the descending order of value to the weight ratio. So item 2 has the highest value to weight ratio, 3.5, that comes first. Second item 3, third item 1. Now the items are sorted in descending order of value to weight ratio. Now we are taking items one by one from the sorted list. Then we can check whether the item can be added or not, cannot be added, or fractional part can be added. So first take the item 2, it's the highest ratio. The weight is 10 kg and value is 35 kg. The weight is added. Now the knapsack capacity is 15 kg. The current weight is 10 kg. So the remaining capacity of the knapsack is 5 kg. So if you take the second item, that is item 3, the weight is 8 kg. We can the balance is 5 kg. So we cannot add 8 kg to the knapsack. That can be overflow. So what we can do, the 8 kg, item 3 can be partitioned or fractioned into 3 kg and 5 kg. Now we can add 5 kg to the knapsack to make it full because the remaining capacity is 5 kg after adding the item 1. So now find the value of 5 kg. So for 8 kg, the value is 25. So for 5 kg, we are finding the value, that is fraction of item 3 taken. So 5 by 8 into 25, the value is 15.625. Now after adding 5 kg of item 3, the knapsack becomes full. So we can stop the process. Now we are going to calculate the total value. So item 2 is completely added. The value is 35 35, and the second item 2, so only 5 kg is added, so the value of 5 kg is 15.625. So add these two value, that is 50.625. That is the maximum or optimal value of items that fit into the knapsack. That is the fractional knapsack problem. And we will see one more example. The knapsack capacity is 50 units. There are 4 items with weight and value. So our goal is to find the most valuable subset that fit into the knapsack. What's the first step? Calculate the value to the weight ratio for all the items. So 60 by 10, 40 by 40, 100 by 20, 120 by 30. So all the values are calculated, value per weight ratio, that is added in the table. Second step is sort the items in the descending order of value to weight ratio. That is item 1 has 6, then item 3 has 5, that comes in second place. Item 4 has the ratio 4, and the item 2 has the minimum 1, that comes in last. Now the items are sorted decreasing order of value to weight ratio. Then step 3, select items to maximize the value. So take all of item 1. So item 1 weight is 10 kg, value is 60 kg, the knapsack capacity is 60 kg. So that is added. 50 minus 10 is 40 kg. This is the balance, knapsack balance. Next, take the third item. The weight is 20 kg. So we have the balance 40. So item 3 completely added. So 40 minus 20, the remaining capacity of knapsack is 20 kg. Now take item 4. Item 4 weight is 30 kg, but we have only remaining capacity knapsack is 20 kg. So we cannot add 30. So 30 kg can be divided into two parts, 20 kg plus 10 kg. The 20 kg of item 4 can be added to the knapsack to make it full. So for 30 kg, the value is 120. So for 20 kg, we are calculating the new value, that is 80 value. Now, after adding 20 kg of item 4, the knapsack becomes full. So this process can be stopped. Now 3 items are added. Item 1 completely added. Item 3 completely added. Item 4 only 20 kg is added. Now add the value of all 3 items. 60 plus 100 plus for 20 kg, the value is 80. So total value is 240. That is 240 is the value of items that is added into the knapsack to make the knapsack full. That is most valuable subset. So that is the optimization maximization problem. The value is 240 units. Now we will see the pseudo code for fractional knapsack problem using greedy approach. Algorithm name is fractional knapsack. The input is knapsack capacity W and the set of items. Each item has value and weight. There are 2 inputs. Then we are taking all the items from 1 to 10. For each item, the ratio is calculated. Value to weight ratio is calculated. That is stored in another array, value per weight. So next, after calculating this, sort the items based on the value to the weight in descending order. So after sorting, so initially the knapsack is empty. We didn't add any item. So current weight is 0. The value is 0. So we are take next the for loop for taking items one by one from the sorter list. Take the first item. So add with the knapsack capacity. If it is less than or equal to knapsack capacity, so the current weight is added with the item weight that is to be added into the knapsack. And the total value is calculated. the total value is current value plus item value. So if we add else part, if we add the item in the knapsack, if the total weights exceeds the knapsack capacity, we are going for fractional. So we are finding the remaining capacity of the knapsack. W is the total capacity that can hold. Current weight is occupied in the knapsack. So we are finding the remaining balance to be added. That is the balance remaining capacity of the knapsack. So only that part of the next item can be added to the knapsack. Then the value is calculated that can be added into the knapsack. So this process is repeated till the knapsack becomes full or all the items are over. So after if any one condition is satisfied, the process will be stopped. The current total value is the optimization or maximization value of objects that is fit into the knapsack. And C program for fractional knapsack problem. So we are using structure to define the property of item. Each item has weight and value. So there are two structure member variables. Then we are using function to swap. When we sort algorithm, we are using swapping concepts. So swap star A, star B, and sort items by ratio. So for sorting, we are using two for loops. So if for is less than R2, swapping. So this function is for sorting the items based on the value to weight ratio in descending order. Now, this is a code for knapsack greedy. So after sorting, we are taking the items one by one from the sorted list. Initially, the total value is 0. The knapsack is empty and the current weight is 0. No product is added into the knapsack. So we are taking for loop I equal to 0 to n. We are taking items one by one. So when we take the item weight is added with the current weight of the knapsack. If it is less than or equal to total capacity, we can add the items in the knapsack and corresponding the total value is updated. If we add other else part, if we add item to the knapsack, if the total weight exceeds the capacity, we are going for fraction or partitioning of the given product. So we are finding the remaining capacity, total capacity of the knapsack and the current weight of the knapsack that gives you the remaining capacity. So that remaining capacity part of the next item can be taken that can be added to the knapsack. So the, for that fractional knapsack, fractional part of item, total value is calculated. So that value can be added to the total value of the knapsack. So this process is repeated until knapsack is full or all the items are over. This is a function for filling the knapsack using greedy approach. And this is a main function. In the main function, we are getting input from the user how many items we are going to have for fractal knapsack problem. Then for each item, get the value and weight of the weight that is added into the structure member variables. Then after that, get the capacity of knapsack. Now calculate the ratio. Okay. Then fill the knapsack or add item to the knapsack by using greedy approach. So that function returns the maximum value. Greedy approach function that returns maximum value of subsets that fit into the knapsack. So that value is printed, that is the maximum value, return 0. This process is stopped till, repeated till knapsack full or all items are over. And the output of C program is enter number of items 3, enter the value and weight of first item 60 and 10, value and weight of second item 120, value and weight of third item 120 and 30, the capacity of knapsack 50, the maximum value subset of items that fit into the knapsack is 240 kg. So this is the output of fractional knapsack problem using greedy approach. Then we have to find the time complexity. How much time algorithm takes to produce the result. So time complexity of fractional knapsack problem using greedy approach. So there are 3 steps. computing value to weight ratio, and sorting the items based on the value to weight ratio in descending order, and filling the knapsack. There are three steps. For the first one, so we are taking all the items, we are finding value to weight ratio. The time complexity of the first step is order of n. N is number of items that can be added to the knapsack. And sort the items by value per weight takes order of n log n. So we can use med sort, quick sort, or insertion sort, bubble sort. So if we use divide and conquer approach, med sort and quick sort algorithm, that takes only order of n log n time. If we go for insertion sort, bubble sort, it take order of n square, quadratic time complexity. So that we are taking the best case for sorting. That is for using quicksort and medsort. It takes order of n log n. So next step is filling the knapsack with involves iterating through sorted list. There are n number of items. If all items are added to the knapsack, time complexity, the worst case is order of n time. So there are three steps. First is process takes order of n, second one order of n log n plus order of n. So when we find the time complexity of complete whole algorithm, so we are adding all the things, order of n plus order of n log n plus order of n. So when we add the time complexity of modules, we are taking the time complexity with the maximum terms. So compared to n log n is maximum term. So that is the time complexity of whole problem. That is overall time complexity of greedy algorithm for solving fractional knapsack problem is order of n log n. And it is very quite efficient because when we solve 0-1 knapsack problem using dynamic approach, it takes order of nw time complexity. So nw value is greater than order of n log n. So this approach take lesser time. N log n is lesser than nw. So fractional knapsack problem can be solved using greedy approach with efficient time complexity called order of n log n. So this is efficient then 0-1 knapsack problem using dynamic approach. Thank you.